enable signal.
Signal. Are you good to go? Yeah, cool. All right, hi. I'm here to talk about MiniScript. We're running a bit late. I'll try to be quick, just like Kelly. MiniScript is a subset of Bitcoin script. It is designed to be very easy to reason about and very easy to solve a wide array of practical problems that Bitcoin wallet developers face when they try to do anything non-trivial or anything more interesting than storing a bunch of keys and producing individual signatures with those individual keys. The history of MiniScript is a little bit interesting. It originally came from work we were doing in the Rust Bitcoin project to support PSBT, that's partially signed Bitcoin transactions. It's a wallet interoperability format where we were working on writing something called a finalizer, which is a PSBT component that collects a whole bunch of participant signatures if you're cooperatively signing a multi-signature transaction or something like that, and assembles a complete transaction, assembles the witnesses and produces something that can actually hit the chain. Carl Dong, who is I believe that chain code and is a contributor to Rust Bitcoin, proposed some code that would do this for a couple special cases, for regular pay-to-pubkey hash outputs and for simple multi-signatures, I think. And I said, no, I refuse to accept this into my library. This is not a library for your specific special cases. This is a library for everyone, so it needs to support all the scripts. And he said, what the hell? How am I supposed to do that? Nobody can do that. And I said, okay, give me 5 minutes. So here we are a year later, and this is the result, is MiniScript, which is a joint work between myself, Peter Willa, and Sanjit Kangalkar. So I have one example to show you here of what Bitcoin script looks like here on the left, and what MiniScript looks like here on the right. So MiniScript has a nice string serialization, but basically, abstractly, it's this tree of combinators. And so I'm going to draw this as a pretty picture rather than the string format. This represents a somewhat complex spending policy for some Bitcoins. You can see you have an OR up here. There are two ways to spend these coins. You can either have signatures from two of these three public keys, or, and then we have an AND here, after 1,000 blocks, then alternately you can sign with this other emergency backout key. So this is kind of a standard claim or refund type construction. So we can see on the left we've got a whole bunch of script opcodes. If I give you this, it's not immediately obvious that this is sound, that it does what, it's not immediately obvious that it's correct, that it does what you expect. It's not obvious that it's sound, meaning that it doesn't do what you don't expect. And it's not obvious how to do fee estimation for this. It's not obvious how to satisfy it. It's really not obvious how to use this at all. Whereas if you look at the representation on the right, first of all, it's visually obvious what the policy looks like. And then programmatically, there's a whole ton of questions that suddenly become very easy to answer. If you have a set of keys, are they necessary to satisfy this? Are they sufficient to satisfy this? If you have signatures, how do you assemble a witness for this? If you have some set of data, keys that you can sign for, or pre-images to hashes, or you happen to know what age your transaction is, so you can satisfy certain time locks. How can you estimate fees? How can you estimate resource usage? How does your policy change as different time locks become available? All these sort of questions become very easy to answer with MiniScript for pretty much arbitrary policies. So if you have any monotone function, meaning just ands and ors and thresholds, of signature checks, hash pre-images, or time locks, you can encode that as a MiniScript, and then you get all of this general analysis stuff for free. So anyone here who's developed a complicated Bitcoin wallet may be familiar with the task of designing a script like the one on the left, and then writing thousands of lines of ad hoc code to deal with this, and then having a result that is completely incompatible with everybody else's wallets, and that's a very frustrating and error-prone and unreliable and wasteful experience. The MiniScript covers all of that. We have a library written in Rust that you can use. You just plug it in. You can take a Bitcoin script like one that you've already deployed, parse it as a MiniScript, you get this kind of representation, and then the library will be able to answer all of the questions that I described. And this is a short talk, so I'm not going to go through the what these different letters mean. But in short, we have a type system in MiniScript. Script is untyped, MiniScript has types. We have a type system that guarantees correctness and soundness, and also a large number of malleability properties, which are important for producing transactions that need to go on the Bitcoin network. Okay, so thank you. Here's the MiniScript website. There's also a Rust library that you can find. I think it's on that website, or you can Google for it, and it will show up. Thanks.